forest and climate. We all are aware that to reduce carbon emission, and construction is a major contributor, therefore we have to play a big role. And since we expect that cooling will increase in this segment and expected to grow much faster than in the industrial or other segments of the economy. By 2030, it is expected that in buildings, cooling capacity required will be at least fourfold as compared to today. So I would like to inform the participants who are new to this workshop. We have already conducted 3 workshops in February and May, and we had discussed different topics. We had various experts with us, and all the recordings are in CIDC YouTube. So those who would like to listen to them, they are welcome to go to CIDC website and YouTube and listen to the previous workshops. To start the program, I would like to invite our Director General, Dr. P.R. Swaroop, to welcome the audience and give the opening remarks. Also, I'd like to mention to all the participants to please keep themselves on mute. And if they have a question, they can raise their hand, and then we'll discuss it at the end of the program. Thank you. And I welcome Dr. Swaroop for the opening address. Thank you.
Thank you, Dr. Kumar. And once again, warm welcome to all the participants who are here in the 4th workshop that is being organized by CIDC under the auspices of Ministry of Environment and Forest. They have an ozone cell, and this ozone cell is responsible for the kind of things that are happening, especially with respect to the commitments that have been given on many international forums, and especially I will mention the Montreal Protocol, where India has made some commitments, and those commitments are there for all of us to support and make sure that we really fulfill and honor whatever are the elements of the commitments that have been made. And that is actually to reduce the carbon footprints, to explore all the possible avenues, to make sure that the life becomes far greener as compared to what it is. And that is where the biggest culprit, unfortunately, as it happens, it is my industry. And as one of the leaders of the industry, I have to basically take a blame. But then there are different reasons for it, not excuses. And we thought that this is the right time to basically set the records straight and to do the things which can really put us in good light and picture. For quite some time now, almost like about 15 to 20 odd years, various small groups have been working, and considering that this problem needs elimination, we have to find ways and means. And then many of the things that have been discussed and deliberated in conferences, seminars, through the research laboratories, the solutions have come. People have started implementing it, albeit in a small measure, but that is not something which is to be feel very disappointed about. I think the beginning has already been made, and now here is a situation where we have to take a conscious leap, and we have to make sure that our people are basically following all the good practices that are needed to achieve this objective, because India has already a very important position in the global community. And almost like every 5th or 6th person on our planet, that basically comes from our land. And therefore, with such a kind of populous presence, I think there are certain responsibilities that are incumbent to us. So many topics have been discussed, and many of the experts are here who have been working on climate control, who had been working on manufacturing practices, and many of them are actually from the practitioners, that is the construction industry experts. And the heartening thing is that in spite of the fact that we could never present a kind of formal picture to anybody that what exactly we are doing, but these conferences have actually been able to collect and collate all the information on a singular platform as to what are the kind of efforts that are happening there. And now the picture doesn't look so bad, frankly speaking. So I have started feeling once again very, very satisfied with the kind of movements that we have. But it is just the beginning of the journey, and I think we have to go long, long miles. And that is where we have to start devising many more ways. What exactly is missing? That bulk of our implementation crews, they are the ones who are actually not familiar with the whole concept or the importance thereof. So that there is a continuous need of constant upgradation programs, skill upgradation programs that have to go on, and you have to keep on drilling it in the heads of everyone who is involved and who is likely to come. And I'm very sure that it is now picking the roots, and very soon things will start happening. So that is the first thing, that is the education and sensitization that we are doing. Second is that we have to really ensure that the good products, which basically conform to certain norms, which basically can prove that these are the good products, green products, and a lot of energy has been conserved, recycling has been done, and many other things. So you have to look at it from many angles for that matter. But then the overall carbon footprints will have to be made assessment of, and good products have to be chosen. We are also trying to work out things with Bureau of Indian Standard, so that the codes of practice that we follow in construction industry, they are properly complemented with the kind of information that comes in. Then comes the third part, and that is actually to look at the kind of processes and procedures. Now, we were having a bit of a discussion in past on the same issue, where the metal product manufacturers, they basically came out and they said that using metal, whether it is zinc, copper, or aluminum, or steel, of course, steel is used copiously in construction activities. So they said that is something always superior, because we have, at least, when the structure goes away, we have the material that can be recycled. And that saves a lot of energy and basically eliminates the carbon footprints. Now, contrary to that, our people, and they basically in a skewed manner were suggesting that basically cement and concrete and masonry, what is being used conventionally in construction industry, possibly that cannot be recycled other than filling the waste dumps and maybe sometimes recycling it while manufacturing some of the binder products and things like that. But then I was very happy because this was also another sub event that we were organizing in Bombay. And we have a wonderful person, Vivek Nayak, who's into manufacturing of construction chemicals. And he has been working extensively on recycling of concrete for that matter. And that is a major menace. And I think if the solutions what Vivek gives, if they can be implemented, and Vivek, believe you me, make it simple to implement, and I will find out someone who will make a demonstration. And that is precisely what we'll
That's
do. We are also talking about,
appreciated.
we are also talking about making certain specifications. I told you about BIS, and I'm so happy to see our CPWD friends from Dharwad. And let me also tell you something that CPWD has been our front running organization, one of the prime members of CIDC. And the beautiful part is that the Director General of CIDC, as per the statutes, is always part of our board, and they had been taking partnership initiatives with us in making many of the good practices applicable. And one of the greatest things that they have done, which has shown light to many of the people in the other state PWD departments, and now even the military engineered services. And sir, please convey it to our Director General also, that now they have also kind of initiated the process of having certain number of work persons thoroughly trained, tested, and certified. Education is the key to everything. The moment a worker gets educated, or he has the pride of having some kind of a certificate which can prove that his credentials are sound and good and he knows about the job, then the life is far easier. You can also teach him many other things, especially on the green side of the construction. And I am really very hopeful that this whole thing is going to pick up steam very soon. And that is precisely I'm looking forward to it. I was meeting with the government of Goa and government of Tamil Nadu during last week, and definitely did share the kind of views that we have had. And they were generally very, very happy about it, especially when I spoke to them about recycling of the concrete, because the new township portions are being built. There is a lot of uh, debris that is being thrown, and they have a problem of basically how to dispose it off and how to dispose it off in a value added kind of manner. And Vivek is again going to be, I'm mentioning him because he's going to be talking about it. That's going to be a very interesting part. So you have plenty of very nice things that are happening. And when I opened up this, as we are reaching to the end of it, and the first draft report that has already been drafted, and very soon, Honorable Minister of Environment and Forest is likely to hold a kind of a general body meeting where all of you will be requested to join, online and offline both. We are not very sure whether he'll be available in Bombay or he'll be available in Delhi, but depending on his location, we are going to be organizing this event very soon. Maybe in next one fortnight, you might be, hearing from us as to where and when this whole thing is going to happen. And that is where I have thought that I am going to take the liberty of proposing to Honorable Minister that let there be some amount of incentivization that should be given to the people who are basically partners in the progress. And this message will go to Central Public Works Department, to the Public Works Department in general, and possibly the incentivization can be done in terms of the recognition, the honors, and of course, monetary support in the sense that not the grants or subsidies, but it's tangible reduction in the taxes that they are likely to pay. So we are going to be working at that. And I think these are the kind of things which will encourage everybody to really start adopting it. After all, go back to your childhood, and whenever you did your sum right, mommy always had some cookie for you. So this is precisely what I'm going to be telling Honorable Minister. With that, thank you so much. It is wonderful to have many of you, many more are likely to join. I was given the number which was larger than this, but I think we have a sizable audience and participants, and we can proceed with it. So enjoy the lectures that are going to be happening. They are all people from industry. You'll have a representative from Tata BlueScope. He'll be talking about certain green products, including, the products which are being used to reduce the temperature so that, the load on the air conditioning and cooling, etc., goes down, and every bit helps. So listen to all of them. And it's wonderful to see you this morning. Uh, Let us take this forward. This is very, very important. Thank you so much. Jai Hind. Thank you.
Thank you, Dr. Sidhu, for setting the pace and giving us the idea what the industry has to do and where we are moving forward. To start the technical sessions, I would like to invite Professor Radhe S. Agrawal. Dr. Agrawal is actually the technical advisor to UNDP and Ozone Cell on Montreal Protocol. He's been the chairman for various international and national organizations and academic societies, including being the chairman of one of the sessions of ECBC in 2017. Dr. Agrawal would be speaking on promoting passive cooling in buildings. To reduce the air conditioning load, we certainly do need passive cooling and certain designs in buildings. So I'd like to welcome Dr. Agrawal for his presentation. Welcome, Dr. Agrawal.
Screen sharing disable करो.
Sir, could we start?
Screen sharing disable करो.
Okay, we'll start the screen sharing. Just a minute.
Can you share we are trying to share the screen.
Okay.
Will it be possible to allow?
Yes, we are allowing it. Just a minute, let me.
Yes, sir, we have given.
Yeah.
Professor Agrawal, the screen sharing has been permitted. Kindly go ahead.
Thank you very much.
Yeah.
So, at the outset, on behalf of the ozone cell, Ministry of Environment and Forest, I congratulate the CIDC for organizing these workshops and reaching out to the the audience or the concerned construction industry stewards. I also welcome to all the participants, speakers and participants. And this present session is very brief, and it's meant basically on passive cooling and low GWP alternatives for HVAC equipment for space cooling. This ozone cell has been working for the implementation of the Montreal Protocol since 1991, and all the obligations of the Montreal Protocol have been successfully implemented so far, and we have changed from number of family of chemicals from one like CFCs and CTC halogens, which were responsible for the emission, and then to in between. Now currently we are implementing the phase out of production and consumption of HCFCs, and these programs are being organized under the what we call the HCFC phase out management plan 2, that the HCFC stage 2. And in the year when we were going through the changeovers from one series of chemicals to another, we faced that, or the ministry recognized that this may not be enough for going from one set of chemicals to another. So we thought, let's look at what actually the overall scenario or overall outlook of the cooling requirements in the country for the next 20 years. So in this background, actually the ministry developed a called India Cooling Action Plan, which was launched in 19. And with that background, actually, I'll be mentioning here in my presentation what actually to be, what sort of approach is required to reduce cooling requirements, and which will reduce the refrigerant requirements as well as the energy consumption. Basically, the cooling is the key for productivity, health, and well-being of the people. Is very well recognized. Cooling demand is growing as our current penetration is quite low, and all of us who are attached with the HVAC industry, we know that more than 85% of the cooling demand is met with the refrigerant-based active cooling, which is very energy intensive. So there is a need to look at how we can reduce the cooling demand as well as the energy consumption in this sector. Next. Actually, currently, what I talked about the low penetration, if we see this present plots, the India has about 69 kilowatt hour per person consumption, where the global average is around 297 or 300 units per person. And this shows actually how the cooling demand is increasing. Currently, our cooling demand is somewhere about 110, 120 million tons of refrigeration, while actually we see in next 20 years by 2037, 38, it will be rising 100 plus. And that means, the cooling demand is growing, will be about 8 times and then further on. And the building sector, why we have actually prioritized this sector, that it is showing that cooling demand in this sector will be rising like 11 times what we have today. Next. This shows the refrigerant demand, the similar scenario. Currently, we have about 25,000 metric ton of refrigerant consumption, which will be rising something in 2037 to 38 to about 140,000 million metric tons. This is the same way the total primary energy requirements, which is also growing very fast, and currently we see about 60 million ton or 65 million tons of oil equivalent, which will be rising somewhere in 270 or 280 million tons of this. So this calls for actually to look all the aspects, how we can reduce the cooling requirement, which will again give us, how to reduce get the reduction in the refrigerant requirements. That means the ozone depletion as well as the climate effects and energy which is used, which gives the indirect emissions, and that is also responsible for global warming, and that should be controlled. Next. Basically, I was looking at, the cooling. If we reduce cooling, it has more impact, much higher impact than even actually energy efficiency of the systems. So even this just shows that even if the COP, which is quite difficult to improve, but even you double the COP, then still it's a small portion of the pie. And so what actually is the more we should emphasize on how to reduce and the cooling requirements, and which is actually simple methods, simple processes, simple construction, processes can reduce the substantially the cooling requirements in buildings. Next. We have taken actually the integrated approach for this. That means we need to reduce cooling and design the energy efficient buildings and the HVACR equipment. Then next comes actually the usage of efficient usage. That means cooling should be used, in a very efficient manner, where we need it, what temperatures we need it, and thirdly, of course, the efficient servicing, maintaining both buildings as well as the HVACR equipment that will provide us, overall energy saving. Next. This, of course, many of us seen. Actually, in buildings, we can consider this, how the cooling loads comes up. One is the building envelope, then of course internal loads, the HVAC equipment, These are the main, and of course, I always emphasize on optimum indoor temperatures, which is very essential to be taken into account. So this presentation is just will touch about the building envelope and HVAC equipment, and thirdly, the optimum indoor temperatures. Next. Of course, this is all known, well known, actually, how this, the larger facade should be in the north and south direction, if possible. It depends on the availability of the land, and but it should be. And of course, we should also see how to reduce the window to wall ratio. Actually, the optimal is 20 to 40%, but definitely, this can be seen. But there are coming up buildings which has as high as 95% of the building window wall ratios, and that's the industry should take into account with respect to the reduction in the cooling loads. Next. Of course, the shading strategy should be worked out properly, and whether it's facing the east-west or south-north-south. So then accordingly, the shading should be worked out. Next. This again gives the various aspects like how the north-south can be, shading can be planned, or then east-west, and there are several others. And of course, tree plantation will always be helpful, both from the point of the health as well as the reduction in the cooling loads. Of course, this is for this industry. I am not the civil engineering side or construction industry side. My main thrust is on the refrigerants and the HVAC equipment. But just to say, in case of the passive cooling, of course, we go for the hollow bricks and the ball air cavities in the balls. This will, since the air is a good conductor, a good insulator, and that will provide a substantial reduction in the cooling loads. Of course, this has started in our country, but more and more emphasis or more and more deployment should go in this direction. Next. Of course, the cool roofs, they are well known now, but still the smaller houses or large number of residential buildings coming up, they are still not doing that or practicing this. And if we see with a normal roof, about only the 17% that solar radiation gets reflected, and remaining are absorbed at the surface and then transmitted to the indoor side or interior. And while if you have a simple painted or reflected paint applied at the roof, it can reflect as much as 87% or so, above 80%. So there are various ways of doing this, and the industry should emphasize on this. And this, if we do the cool roof, provide the cool roof, you can see the indoor temperature, surface temperature from 80 degrees centigrade to reduces to 50 degrees Celsius or something in this order. And the indoor temperatures are affected significantly from 34 degrees and 27 degrees. So this actually is a very effective way of curtailing the heat loads within the space, both in the non-conditioned and the conditioned space. Next. This shows actually about the application of the insulation in walls, roofs, all actually this can be applied. Next. The living walls is also one idea, but may not be possible in all sites, but wherever possible, we should deploy. It looks good. It beautifies the building as well as gives the good ambience, and the reduces the cooling loads. The ventilation, of course, all of us understand the proper ventilation, especially for the all non-conditioned buildings, normal conditions, housing, commercial buildings, all actually the ventilation should be planned, the light should be planned properly. Next slide. Next. Just now I'll give the glimpses of the Monterey Protocol. This slide gives actually, of course, there's a very elementary process shown on this slide. The chain reaction of ozone depleting substances on the stratospheric ozone. So we see the UV radiation falls when the the chlorine or bromine containing compounds reaches to the stratosphere. They breaks down and it gives the chlorine or bromine radical, which is very reactive, and that reacts with the ozone and converts to oxygen and a compound called chlorine monoxide. And this chlorine monoxide happens to be unstable compound, and so this again breaks it and gives the chlorine radical, and that's how the chain goes on. So the one molecule can damage or convert or deplete the ozone, say about 10,000 molecules of the ozone. So this is how actually this chain reaction got depleted, responsible for the depletion of the ozone layer. And of course, with the Monterey Protocol efforts, all ozone depleting substances have been more or less phased out. Production and consumption of these have been phased out, and only little bit of last phase of the HCFCs is going on. And this has put the ozone layer on a path of recovery. And by 2060 or so, the ozone layer will be recovered to a level of what we had the pre-industrialization somewhere in 1970s and 80s. Next. This, of course, well known actually how the global warming is taking place, and all we are aware there are 7 global greenhouse gases, and HFCs is one of them. And that is actually, again, contributing the production and consumption of HFCs is increasing as they were introduced as the alternatives to CFCs, CTC, halogens, all these ozone depleting substances. So now actually HFCs and there is a growing demand of HFCs. If I say there is an exponential growth of production and consumption and use of these HFCs. And so that's how we moved to the, in 2016, next slide. This shows actually the growth of the HFCs. If we take, this will be responsible about 0.3 to 0.5 degrees Celsius rise in global temperature, average global temperature by the end of the century. And that actually motivated to take some action on growth of the HFCs. And with that, we came to the Kigali Amendment. Next slide. And Kigali Amendment, that is again taken up. Of course, the HFCs happens to be non-ODS, and they are not. And the Monterey Protocol was basically came in existence without production and consumption of ozone depleting substances. But HFCs, since they were introduced, so actually there are 2 sets of schedules of the HFCs, and one is, of course, I have taken only for the developing countries here, And we have the two groups, Group 1 and Group 2. India has adopted Group 2, which is little favorable to us because the present consumption of HFCs in our country is not as much as what it should be due to the very fact, as I mentioned, that the penetration of cooling is low currently, but it is growing very fast. So we are in the Group 2, and starting from 2030 to 2047, we will be phase downing all HFCs, production and consumption of HFCs to 15%. Of course, we may not find all, the alternatives, with a zero GWPs, and that's how actually there is towards the end we will be surviving with that section, with the within the 15% of the baseline, and baseline is of the average production and consumption of HFCs in 2024, 2025, and 2026. And over and above, we will be getting 65% of the HFC baseline. So this is well negotiated, and we will be providing some comfort to the industry. Next. Of course, if we go to the alternatives to HFCs, then what we are looking for, lower emissions, that means the lower GWP, and the energy efficiency. The refrigerant should be energy efficient, or the equipment should be made energy efficient. Buildings should be energy efficient. And so these are the two main elements which are essential for you can do the selection of the refrigerants. And next. If I see, of course, this may not be that important for the audience. Actually, we have the two family of refrigerants, natural refrigerants, and the fluorocarbon refrigerants. And if we see in that, actually, in the natural refrigerants, we have like isobutane 600A, R290, propane, ammonia, CO2, which were very largely used before invent of CFCs or the fluorocarbon refrigerants. But as their flammability, toxicity, they were the concerns, and we moved to the fluorocarbon refrigerants. And in the fluorocarbon, again, there are three category of applications: the high pressure application, medium pressure, and low pressure. High pressure, normally currently we are using SCFC 22, and the replacement in the low GWP is 32. Then medium pressure, of course, 134A is very by and large used, and where actually the alternatives which are coming up is the like 1234YF, which is a hydrofluoroolefin, and which has a GWP of 1 or less than 1. And similarly, other HFOs, and of course, one of the HFCs, 152A, which has around 127 GWP, may also be useful. For the low pressure chillers, actually, again, the alternate currently uses the 123 SCFC, and where we can go for 1233ZB or 1330Z and ZZ. Of course, these can't be remembered, but industry knows very well, and HVAC industry knows very well, and the manufacturing industry is quite conversant. Next. Of course, this again gives the last slide. There are limited single component lower refrigerants. So the industry is going for, and majority of them, you see they are highly flammable, like A3 classification of the ASHRAE, or mildly flammable, that is A2L, and but they are, and some of them are both flammable and toxic. So there is of course, attempts are being made, or a lot of work is going on how to have these safety standards for such refrigerants, because the future refrigerants are going to be in these categories. And industry to also synthesizing a number of blends of HFCs, HFOs, and to have the lower of this chemical. This shows actually what sort of equipment is used in the industry in the space cooling area. Of course, for the room air conditioners, all of us are very well aware, and they are both window type as well as the split air conditioners. And basically HCFC 22 was the main, and then it moved to 410A, 47C. I'm sorry, there's a mistake. No, not 407A, but it should be 407C. And all these were the non-flammable, but high GWP of the order of 2000. And then, of course, the ducted, we see, again, this uses the 22 and where, which has a GWP of 1800. And of course, so then scroll in the same category, and screw chillers, they are mostly using 134A, which has a GWP of 1430, and of course, A1 category, and then centrifugal chillers, 123, and also the 134A. Both refrigerants are common in centrifugal chillers. And again, the 123, though it has a low GWP of the order of 70, but this is one of the ozone depleting substance. So it is to be phased out by 2025. New manufacturing will end from 1st January 2025. Next slide. Now this slide presents actually what are the potential alternatives, and some are commercialized, some are in the process of commercialization. So we see for the room ACs, the 32, as I mentioned earlier, this is one of the potential refrigerant, but it is still a HFCs. So this is also a transitional alternative, maybe by somewhere 2035 or so, we may have to also phase down this or phase out this refrigerant. Of course, the next is the R290 flammable, and then new alternatives, blends are coming up, 452B, 404B, and there are several. If I'm right, you should recall, about 150 blends have been synthesized by the chemical producers, but still very few have been put in the use. Then for ducted, again 32, 452B, and this 454A is likely to come, which has a very low GWP of around 230 or 240. And similarly, if we go to the scroll, there also it has a potential 32 as well as the 454A. And the screw chillers, one option is 513A or HFO 1234YF. Basically, there are some chillers which are being commissioned with 1234YF as well as 513A. The centrifugal chillers, they have actually the two categories: medium, where 134A was used, and which has again the same as is given under the screw chillers, and the low pressure chillers, large capacity centrifugal chillers, and which the alternatives, these two HFOs has come very well. And even actually the R514A is considered very potential refrigerant, and there are some installations even in Delhi, in the Pragati Maidan, with this refrigerant, a large number of chillers have been commissioned in that next. This slide shows actually the various, installation. Of course, there are plenty of them, but I have picked up a few. And if you see, these are Paryavar Bhavan, Indra Paryavar Bhavan is actually again very, energy efficient building. It has, net positive energy building, we can call it. Of course, there are many, categorization or, of these buildings, but it has of EPI of only 43 or 44 kilowatt hour per meter square per year. So that's a very positive way, and similar approaches are required. Then, of course, we see that there are installations. The textile industry, the evaporative cooling is quite common. Even it can be put to use in evaporative cooling in the large buildings where actually the temperature requirements are not that sensitive. Then, of course, the alternative technology like district cooling and the trigeneration, these are also becoming as a potential because actually district cooling, wherever we find a complex or a mixed cooling requirements, where the office building which need the cooling during the day and the residential more load is in the night hours or the late evenings and the night hours. This sort of gives a diversity of the load and where the district cooling, it may be quite helpful in reducing the refrigerant use, the installation capacity, first of all, that is the refrigerant use and the energy conversion. Of course, the gift city, of course, there are several installations are coming in the country in this direction. The trigeneration is another where actually the cooling, heating, and power generation all are required. This can also be in Delhi. Is the All India Institute of Medical Science at Trauma Center has this a plant has been commissioned and it's working very well. Next slide. I'll just end with this and next slide. Actually, it is actually again, if you see the indoor temperatures, the industry should work what should be the optimal indoor temperature. As per the ASHRAE defined, 25 plus minus 1 is the optimum temperature. While most of the installations, we see they are operating between the 20 and 22 degrees Celsius, and which provides a very high energy penalty on operation. It also demands for the higher cooling equipment to be installed. And if we see this, we optimize this, though the Bureau of Energy Efficiency has, based on the ICAP, recommendations, has, put the the default setting for the air conditioner at 24 degrees Celsius. But still people have the remote in their hands and they can go down, and normally they go down to that. Next slide. Just actually, if you see, by changing these or maintaining these temperatures in this way, we can save energy of the order of 25 to 30%, which is quite difficult to achieve by different modes. And I again here, request the council to have a look on these aspects along with the HVACR industry and have this, because our workers actually in the field, those who construct the buildings, they are exposed to 45 plus temperatures. So And while actually once the building is ready, we are looking for 22 degrees Celsius. So there is a lot of disparity in this, and that should be taken care of. Thank you very much for the giving me time and paid attention. Thank you very much.
Thank you, Dr. Agarwal. A very interesting thing and thought-provoking things that need to be recognized by the industry personnel. So thank you, sir. And it was really enlightening. So now I would like to invite our next speaker, is Shri Vikram Murthy. Mr. Vikram Murthy has been with us earlier also and spoken on various topics of importance. He is the director of Univac Environment Systems Private Limited, Mumbai, for indoor environment engineering works. He is also a trustee of Tropical Air Conditioning and Refrigeration Institute. He is the India representative of Air Conditioning and Heating Refrigeration Institute. And earlier, Mr. Murthy has spoken on adaptive comfort, where we should align our body heat to balance with the surroundings, which is a possibility, very interesting, and non-ODS and low GWP based refrigerants. He has also shared his thoughts on reimagining the built environment. Today, he will be speaking on passive structure cooling and radiant cooling. We all look forward to listen to Mr. Vikram Murthy. I invite you, sir.
Yes, just give me a minute. I'm trying to put
Okay.
this on slideshow.
And in the meanwhile, I'd like to request all the participants to please be on mute so that we are not interrupted during the presentations. Thank you.
Yes. So I don't think you can see can you see my screen now? 1 minute.
Yes, we can.
Oh, you can. Very good.
We can.
Okay, good. So today I am going to speak about the principles of radiant cooling. We might talk a little bit about the technology, but it's more important to understand the principles and why radiant cooling is the most efficient and the best way of cooling compared to conventional cooling, where we use air as a medium to cool our whole space, and we end up cooling the whole space, and as a result we also feel cool. Lots of energy is spent to circulate that cold air. First of all, energy is spent to cool that cold air, and then energy is spent to distribute that cold air and push it out of ducts and so on and so forth. And so you can see how much of energy is spent. However, air is a very poor conductor of heat. It is actually an insulator, and therefore it is not at all effective in cooling unless it blows at a higher velocity over your body and it is colder than your body. So you can see that's a very inefficient way of cooling, but it is the most effective and practical way of cooling, and that's why it still continues. Water has a much higher specific heat than air, and so it is able to transport thermal energy 3,000 times more effective than air. Also, the energy required to circulate water and not have to circulate air results in savings of 70% of the energy. So here is, let's go to the slides now. I'll put on a pointer so we can show you what I want to say more effectively. So just give me a minute. Where is the pointer? Okay, the pointer will come up very shortly. So if we have surfaces which are cooler, maybe the roof, the floor, or the walls, then we have a situation where there is no need to spend so much of energy to cool the person inside. And Dr. Agarwal spoke of many methods of passive cooling. So one of the methods is to have the walls and the roofs cooler. He spoke about cool roofs. We can even have cooler walls and floors by circulating water through them, whether the water is cooled by a refrigeration process, whether the water is cooled by an evaporative natural cooling process. All of these will help to bring down the temperature of the walls and roofs, and thereby less load inside the space. But what is the most significant part in all of this? Your body is at 37 degrees centigrade. So it is naturally radiating heat if the space around you is cooler, right? If the space around you is warmer than 37, if it is 40, then your body is not able to lose heat so fast, and the body feels extremely uncomfortable, as it does in the hot Indian summers. So if you're in a space which around you, surrounding walls and surfaces are cooler, your body will naturally radiate heat. Imagine you're standing on a hot summer's day near a fountain, which is spraying water. So water is evaporating, it is much cooler. Your body will rapidly lose heat by radiation to that water, right? Or if you go to a supermarket where they have open refrigerators, where they are cooling dairy products, then your body will naturally use heat and you feel cooler because of the process of radiation. In the process of radiant cooling, we don't have to heat or cool the whole space. It's not necessary. We only have to cool surfaces so they rapidly suck away heat from the body and you feel comfortable. If you want to feel more comfortable, you can gently put on a fan to have some air circulation, and this is what happens. So radiant cooling is a technology based on the sensible heat absorption through cold surfaces, right? So that's what you can see. If surfaces are cooler around you, you will lose heat faster. Open your fridge door, stand in front of it. Your body rapidly loses heat to the coolness of the fridge. Of course, you cannot keep the fridge door open for long, otherwise the fridge will stop working. So this is some physics to tell you that radiation and electromagnetic radiation travels in absolutely straight lines, mostly in the infrared part of the spectrum. And so that is how the sun heats up the earth from 93 million miles away so effectively without having any medium, right? So the infrared spectrum is where the maximum radiation takes place. So visible light emitted by a bulb, if you go close to a bulb, you feel the effect of heat. So radiation can produce your body to feel warmer, as you feel from a heater in the cold Delhi winters, a radiation heater, or from the sun, which we feel every day. The sun is able to radiate heat so effectively, and light. So radiant heating and cooling operate at a temperature with emission in the infrared, which is invisible to the human eye, right? But it works very effectively. So thermal radiation, radiant cooling, if you have surfaces which are cooler, your body will lose heat faster. If you have surfaces which are warmer, your body will gain heat faster by radiation. So radiation can be used for cooling in the summer and for heating in the winter, right? So winter heating is possible. So why do you feel comfort with radiation? Because we have many sensory organs in our body, such as the eyes, the nose, the ears, and tactile receptors on our skin. So the skin is a highly receptive surface for heat transfer, which is why your body, if you have less covering clothes in the summer, you can radiate heat much faster. And if you cover them in the winter, radiation doesn't take place and you lose heat more slowly. And your nose is extremely sensitive to heat or cold. You know that very well, right? And so is your head, so is your neck, so are your ears. In the winter, you go to some cold part of India or cold part of America, Europe. In the winter, when it's cold, your ears feel coldest the fastest. You go to Shimla in the winter, you better wear a cover, cap, woolen hat over your head to protect your head as well as your ears. Your eyes might start watering when it's very cold. Anyway, so thermal comfort is a state of mind. Just remember that. You can teach yourself by good yoga, by good meditation, not to feel so hot, not to feel so cold, because your mind controls everything in your body. Of course, your physical being is very much the experience part of it, but you can really not have to feel so hot at 26 degrees centigrade, as Dr. Agarwal mentioned, because it's quite a normal condition. You run your air conditioning at 26, 27. In Mumbai, you can even run it at 30 and put on the fan and feel very comfortable, right? That's what I do in my home. So this is not true that if you put one leg in ice and another leg in cold water, you will feel the average of the two conditions. No, that's not the case, because the body's sensory perception depends on the skin, depends on your nose, your eyes, your hands, and how fast you're losing or gaining heat, right? So the factors that affect your comfort are air temperature in normal air conditioning, the radiant temperature of the surrounding surfaces. Even in very comfortably air-conditioned buildings in Gurgaon, which are set at 22, because the glass is so warm because of radiation, the people sitting near the glass, they feel extremely uncomfortable because the heat of the glass, the hot glass is radiating heat to their bodies despite the cold air from the air conditioning surrounding them. So actually their body is completely confused and they are very uncomfortable. Humidity is important, right? If the humidity is high, we cannot lose heat by perspiration. So there is some need, in spite of doing radiant cooling, that you have to remove the humidity, but I'll speak about that later. And of course, the air motion. And all these other things are quite incidental. They're not the topic of our discussion today. The aesthetics, the acoustics, the dust, the odor, the lighting, all these things make you feel more and more comfortable. The advantages of radiant cooling system are many. Can you, sorry, Ruchita, you can hear me? Hello.
Yes, we can hear you.
Yeah. So I request.
There's been some disturbance, I guess.
Yeah, that's okay. So I request all to please be on mute. We can answer questions later. There are many advantages, as you can see here. I'm not going to read all of them, but one of the big ones is energy saving. And of course, there's low sound because there is no sound of air moving around. There is no dust movement. And in humidity in winter or summer, you can arrange with an alternate system and not have to spend so much of energy. So in radiant cooling, all the transmission is done mainly by radiation of the body. The body is warmer, so it can lose heat quickly to a cooler surface. Air motion, if it is there, will improve it. And convection, if it is there, it will improve it even further. And of course, some evaporation will take place. Because in the end, the radiant cooling walls will also cool the room, because the room surfaces which are hot will start losing the heat also to the cooler walls. And therefore, in the end, your body will also lose heat by evaporation when it is not able to balance its comfort very well. So when you do air conditioning, it is quite different. Most of the heat transfer is taking place by convection and very little by radiation, because the diffusers and the ducts are very cold. So there might be some radiation to those surfaces, but they are very small. So therefore, they will not be so effective. So therefore, this picture is to tell you that in radiant cooling or heating, when you do it in a radiant way, there is quite an even temperature difference all across, because a whole wall or a whole ceiling is getting the effect of radiation being removed. Whereas in a convectional way, convection, there will be some parts which are cooler, there will be some parts which are warmer. If the diffuser is up over there, it will be cooler at the top and less cool at the bottom. So there's discomfort depending on where you are in that system. And radiation provides uniform heating or cooling. Many places now are using floor pipes buried in the floor. In Hyderabad, which is my hometown, because I live in Mumbai, there are many examples of radiant cooling now in residential places, in commercial spaces, in malls. There was one big mall which was cooled by DX air conditioning. It has been completely converted to radiant cooling, and it's so comfortable, and energy savings are 30 to 35%. And everyone's feeling very good about that project. Again, the same thing, that cooling by convection is not uniform. Office spaces also can benefit greatly by radiant cooling. If you have these convectors or diffusers or cooling units or high wall units, some guys are comfortable, some guys are not comfortable. Why is this guy uncomfortable? Because he's getting too much of cold air. Why is this guy feeling good? Because he's getting a mixture of air and he feels good. In radiant cooling, because the whole ceiling is cooled or the walls are cooled, there's an even rejection of heat by the bodies to that cooler surface. Now, of course, acoustic comfort, aesthetics. So because you don't see many ducts, you don't see many ugly structures around the place, architects love it. Radiant panels can be just looking like any other ceiling. So it's aesthetically very good. I will just pause over here to say one thing, that this is a whole lecture and discussion series on natural processes of cooling. So while I might be speaking of radiant cooling requiring pipes to be buried and putting refrigerated water inside those pipes, the water temperature is not as cold as the air conditioning cooling water in a chilled water system, which is 7 to 8 to 9 degrees. Here the water can be as high as 17, 18, 16 degrees centigrade, because effectively then the wall surfaces become that same temperature or 1 degree higher. And there is a huge difference of temperature between that wall surface and your body at 37. So we will see now the equation about why it helps to have that temperature difference and have a quick transfer of heat. But if humidity is to be removed, we can have a supplementary system of cooler air, because humidity and latent loads are not even 10-15% in most cases, except in more humid climates or high occupancy. So it is very easily handled. So I have seen a project in Maharashtra, which was done by a good consultant for a educational place, where they use two-stage evaporative cooled water down to 20 degrees centigrade because Pune is dry, and circulated those in pipes in that whole area of the classrooms and laboratories and everywhere else at 20, 21 degrees, and put on fans, and everybody felt so comfortable. Of course, over there, because the air is clean outside, they also allowed some natural ventilation. So really speaking, the humidity never got higher because it goes away with natural ventilation. And so much of energy was saved because the process of two-stage cooling requires one stage of sensible cooling, which is again by a natural process, not by a mechanical process, except for the pumping of the water and some fans to circulate ceiling fan air inside. So you can even use that for radiant cooling, where you have the advantage of low wet bulb temperature, and where the places you want better comfort and lower apparent conditions inside, then you can use refrigerated water and bring down refrigeration to bring down the water to 18, 17 degrees centigrade. And so Infosys is a wonderful company, not because of their business, but because they have adopted radiant cooling as the de facto way of cooling all their large campuses. In Mysore, in Hyderabad, many other places, they are doing radiant cooling, and they did 2 separate buildings, and the savings was demonstrated over 2 successive years as 35% energy saving. I'll not speak much about this zoning and all because these are more technical things, but radiant coolings are projected to save 42% compared with air-based cooling systems. And how does it save energy? Because of the principle of physics. Water has roughly 3,500 times the energy transport capacity of air. Of course, we cannot shower you with water to make you cool. That's a very shall we say, that's good to have a shower or something like that, but we cannot cool people by spraying water on them. But the point is, we can transport cold water and let it be circulating in pipes around, which are buried in walls and buried in the floor. These are all plastic pipes, and the pumping energy is not very significant. And the transport of pipes, the laying of pipes is a very easy process, which can be done while the building is constructed, or even after by raising the floor by just 3 or 4 inches. And so it's very quickly done. And the water is the medium of removing the heat constantly. The pipes get a little warmer because of radiation of your body. You take away the water, you cool it again, whichever process you're using, refrigeration, evaporative cooling. And then the energy required is only the pump energy, because we no longer have to spend a lot of energy with fans or air handling units to pump air all over the place. And such a huge quantity of air is required, right? So energy saving is given. This is measured. The Lawrence Berkeley Laboratory ran a detailed simulation in office buildings, and they compared it all very well. And they could see that so much of energy saving was there. Even the chiller loads were substantially less compared to the conventional cooling. So what is the advantage? We don't have to have lots of ducts. We have shorter ceiling floors because we don't have ducts buried either in the ceiling or in the floor, not buried, but suspended. And we can add 1 floor for every 5 floors. Allow ceilings to be raised. Architecturally, you have 9 feet ceilings or 10 feet ceilings. It is so much more, right? And because there's no movement of air, the dust circulation also is completely less. Also, doors and windows are kept normally cool. And so instead of having a refrigeration system producing cold water, you can have an evaporative cooling system producing cooler water in drier climates and circulate them to multiple areas. You can have controllers to switch on and switch off the pipe distribution, and everything can be controlled very accurately. So, sensible heat is removed by a radiant cooling system. That is your body's temperature heat. How is the moisture removed? So moisture is removed from our body by evaporation in the form of moisture droplets or particles on your skin. And that process improves faster and faster with some air circulation. So we can aid moisture removal by air circulation by simple ceiling fans. And we can also do it actively by circulating some cold air in the ceiling, which is at lower temperature than the dew point. And then all the moisture can be removed very quickly. You can also bring in some fresh air in that process. And of course, there are many ways of doing this gradient cooling panels, which are in ceilings and walls and floors. You can have it buried in the surface, as you can see. In the interest of time, I'm going a little faster because we have some wonderful speakers after me. And depending on where you bury your pipes, the response time is very good, and you can have lots of panels. So this whole thing about dew point, we cannot cool the surfaces so cold that moisture starts condensing on the walls. So we have to be mindful of that. So dew point control has to be carefully done. But radiant cooling is removing sensible heat very fast. So here is the equation which is governing radiant cooling by the Stefan Boltzmann equation. So the important point to see that it is dependent on the fourth power of the temperature difference. That's the key matter. So the temperature difference of the surface and the other hot surfaces, including your body, the delta T, the 4 power times of the difference increases the rate of cooling. So there's a larger temperature difference, the rate of cooling is much faster. Also the area of exposure, that is very important. So then you have higher area of exposure, the heat transfer is much faster, right? So this is, I prepared this presentation for another program where I was teaching a workshop about how to do all the calculations for radiant cooling. And so there are some nomographs and many other tools are there. And this is also available in software for quickly doing all of this. And so I encourage that those who want to learn all about this, we can refer to an article which I'm happy to share with the audience here today. And you can study all about how to design air cooling. So coming to the end, I'm showing you some pictures of how pipes are buried in the ceiling. In the floor, you can imagine how that is done faster. But the essence of what I'm saying is that radiant cooling principle is losing heat by radiation instead of trying to cool you by convection air. That is the principle of radiation. It works very well. And so we can have all these aggregators for distributing energy. You can have sophisticated control for changing the water direction and flow. You can also change the temperature of the water depending on the time of the year. And you can do all very amazing things with radiant cooling. It is a little slow process in the beginning, that the places have to be cool, and it takes some time for you to feel effectively cooler. But that can be increased by you passing through a place where there is more air circulation as you enter the space. See this wonderful gym, and the whole ceiling is having radiant cooling panels. So this lady who's exercising is feeling wonderfully comfortable. No noise, no cold air coming on her, and a very silent gym, right? And so people are making these wonderful panels. Installation is very easy. So I think I will stop sharing now. I went a little fast because I want to hear all the other speakers, like all of you. And if there are any questions, I'll answer them in the end, most willingly and happily. Thank you very much, Suchita.
Thank you, Mr. Murthy. As usual, it's very interesting. I enjoy listening to you. So I'm sure people who like to ask questions and make it feasible and more used to. Right now, it's a new concept. So we're not embedded in our thought that we are. So for the next session, we have Mr. Ajay Ratan. Mr. Ajay Ratan is the Associate Vice President, Corporate Services with Tata BlueScope Steel. He's a civil engineer and he has more than 30 years of experience in the construction industry. He is a certified lead auditor and he heads corporate services, which includes portfolio of sustainability. So that's what we are looking forward to. And under his leadership, his companies have won prestigious Vishkarma Awards from CIDC as well. Mr. Ajay Ratan will be speaking on securing your future with sustainability in the construction industry. I look forward. Mr. Ajay Ratan.
Thank you, Doctor. And I first, at the beginning, I must at the onset, I must thank CIDC for allowing us or giving us opportunity to share our thoughts. So first of all, am I audible properly, and can you all see my presentation, please?
Yes, you are audible and you can make your presentation full screen.
No, yeah,
that helps.
Yeah.
Thank you.
Right. So this presentation, first of all, is not about the product presentation. It is about the sustainability, what we talk, because we all know construction industry is one of the largest employer also industry, which employs a lot of workforce. At the same time, it is unfortunately also, it creates a lot of pollution by the way of the raw material that we use, be it steel or cement. So we have to be very cautious about that. And all alone, by producing green products alone, may not suffice, because good products, if they're not utilized properly or not applied or installed properly, also lead to some bad applications. That's why this sustainability, what we talk in our company, includes all of these. It talks about green products, governance, the skill development, and also the D&I, what is the diversity and inclusion. It talks about the safety of workforce, because it impacts all of this. I will try to run through a bit fast, as I understand that we are just missing with some timeline. So the content of the presentation would cover all of this. It talks about sustainability. What is this? Challenges that construction industry is facing to ensure sustainability, or I would say net zero. As we all know, our honorable Prime Minister has taken a, I would say, commitment, has given a commitment that by 2070, India would be net zero. As in the similar lines, Mr. T.V. Narendra, our Tata Steel MD, also has taken up a sort of a challenge to be net zero by 2045. And this was, again, this is not about concrete versus or cement versus steel. It's about steel and the features of the steel. So let me talk about the company first. This is an equal joint venture between Tata Steel and BlueScope Steel Australia. What is Tata Steel in India is BlueScope Steel in Australia. BlueScope is the inventor of the technology, the color coating of the steel. So steel was always remembered as a strong product in construction industry. But by this technology, invention or intervention, now steel has produced beautiful buildings all across. You name any landmark building, be it Petronas Tower, be it your stadiums, Olympic stadiums, airports, Changi Airport, in the country also metro railways, everywhere you'll find that BlueScope's products are used. We've got very strong and time-tested products. This company has got three major verticals. First vertical is coated steel. We produce coils, color-coated coils. We use only lead-free paint so that these products can be used for rainwater harvesting also. And we use Thermatec technology in our color product. By virtue of this, it has got very high solar reflectivity index, the SRI value, due to which the rooms below or the building below, the temperature gets reduced by up to 6 degrees by using Thermatec technology. Then we have our building products division, which basically takes up the supplying of the products to projects like metro or railway stations or airport building. Also, we have got a Durashine channel, which has got almost 5,000 dealers across the country to supply products through retail channel. And then we have got a complete building solution also, which takes up the projects of complete building. We are present all across the country. We are registered offices in Pune, and we got 12 sales offices, and we got metal coating line and paint line in Jamshedpur, and we got 5 manufacturing units all across the country. Sustainability, what we feel that sustainability for us means it's just like cycle. It's a cycle. You get less resources, you make smart and innovative products out of it, you use it till its complete life cycle, and last bit is most important: can you recycle it? Can you reuse it? That is where it makes cyclic in nature. Otherwise, if it's like linear usage, then we are adding to the carbon footprint of the country. So this is what we believe in BlueScope. And these are 2 important studies which I shared in the last conference also. Now, this is a model which is known as Stockholm Resilience Model, which is created by Stockholm University. And the environmental engineers have divided the entire Earth into 9 planetary bodies. And as per them, the green zone is where the Earth, the Mother Nature has got resilience. So that means you use resources and you generate waste. As long as you are in the green zone, the Earth is able to generate or accept that. It's like polluting river. There's a limit beyond which river cannot refresh herself. The moment you enter into yellow zone, then you are entering into some area of uncertainty. And when you enter into red zone, then that means that you have reached or you have breached the boundary to a level where from where it will be very difficult to come back. Unfortunately, out of these nine boundaries, we have already breached 7 boundaries. So that is point of concern. Second is around that we all know. This is Earth Overshoot Day. This is again a data where Ministry of Environment all across the country, they try to map the Earth Overshoot Day. Earth Overshoot Day means ideally Earth Overshoot Day should happen in the month of December. As you say, in 1971, the Earth was able to recuperate whatever waste was generated. Unfortunately, this year, our Earth Overshoot Day happened in July. That means we are still left with 5 months, and we are going to use our resources again to manage our day-to-day working. And at the top, if you see, that means we require almost 2 times Earth to take care of the waste that we are generating. So this is point of concern. But the good thing is, as I said, now all across the globe, there is an awareness around that, and people are working for the, I would say, sustainable products. Steel, as I said, since I am coming from steel industry, I'm going to talk only about steel. Steel is a cyclic product. It forms is a very integral part of the cyclic economy. Though steel industry itself produces a lot of this, leaves a lot of carbon footprint. And recently, Sweden has come up with the green steel, where they claim that the steel also is green, but a lot to be done here also. Why steel is a cyclic product? Because it is very easy to reduce. You reduce by using less material. It follows 4 principles of R, that is reduce, reuse. It is very easy to reuse. You can remanufacture. The best thing is you can recycle. In the country, almost 40% of steel requirement comes through recycling only. And we are falling short of this material. A lot of recycled material comes as import. Steel is strong. We all know it is 100% recyclable. It is recoverable. That is most important. One is recyclable, recoverable. Almost 85% of construction can be, the steel can be recovered from the construction. And it saves a lot of carbon emission. This is a small study on the per capita consumption of steel and cement. Where do we stand? Where does India stand? If you see that a lot to be done here also to improve our consumption part as compared to global average or even China for that matter. Challenges of construction, as I said, all alone products may not solve the problem of sustainability or your climate change. We should bring some focus. What material to be preferred, and this is item we should start differentiating green product or the products where they are sustainable product versus those are not sustainable products. And a lot of good work. I met Dr. Vivek also, very good work he's also doing the recycling of concrete products also. So there are a lot of admixtures are there which enhances the life of concrete, which reduces the water consumption. Similarly, a lot of smart seals also, or like for example, the precast concrete, where you, instead of wire you use instead of bar you use crystal strands. So a lot of innovation is required to be in fact focused upon to bring sustainability in the construction industry. As I said that we should focus on the green certifications also, and we are very proud to say that we are the first one in the country to get all this certification. We recently got GREA certification. This is by Ministry of TERI, if I'm not TERI and MNRE, Ministry of New Renewable Energy Sources. We are also Green Pro certified company through IGBC. And recently we also got Environment Product Declaration. Now this is one step towards knowing our carbon footprint that we are leaving. So this is just like a report card, and we know our EPD now. It talks from end to end, the carbon footprint that you're leaving. So these kind of certification, a lot of state governments are also giving a lot of incentives towards having this certification. And similarly, the consultants and the designers should also focus on these certifications, which are so important for us to leave a very good legacy for our coming generation. As I said, all along products may not solve the problem. You require skilled workforce. They should know how to use this product effectively. And that is where certification programs are required. Unfortunately, I was talking to Dr. Sarup and his team a couple of occasions. There are now a lot of companies coming up for certification programs and skill development of construction worker, but still construction industry, we use a lot of workforce which is non-skilled. Straight away they come from agriculture field, they just climb on the top of the roof, especially if I talk about construction building. We made Kalinganagar steel plant, which was 90-meter height, and 90-meter workers working there. If they're not certified, you can imagine what kind of accidents can happen, and there are accidents happening all across. And we need to think seriously about certification of workforce. And connected to this is the site safety, especially when I talk about steel construction, steel buildings. The good part is that the entire product is the quality is maintained because the entire product comes from the factory. It's like factory controlled quality parameters. But the second part, the deployment part, the implementation part, that is where we need to focus, because there are good companies where they focus on site safety also, but hardly I have seen in the tenders where the vendors are differentiated based upon the safety parameters you're talking. I'll just tell you one example. Like we also provide scaffolding, we also use scaffolding to climb. And in fact, now we have gone to products like mast climbers or cranes being used frequently, but I think we would be the first one to use mast climber, where 100 workers can work simultaneously at a height of 80 meters or so, working with the heavy loads. So coming back to the scaffolding, for example, so we use, as per our norms, we use only 4-legged scaffolding. That means this is much stable, I would say stable scaffolding. But if you do not specify clearly, there are 2-legged scaffolding also, which are connected with the building. So that will reduce the cost for the contractor. So we need to be very mindful while framing the specifications that safety, there is no scope for anyone to play with the specifications and also with the life of the workers. And as I said, diversity and inclusion looks like a far dream as of now in construction industry. We hardly see any women contractors or women supervisors. What we see is a women labor. So we have seen that wherever women have come there in the fore or in the front, they bring in a lot of new ideas. But are we providing conducive environment for these women to work at the construction site? Again, we need to see. And I'm sure with these changes, it will end up having sustainability. The carbon footprint will definitely reduce down. I'm not talking much about that safety part. I'm just skipping that. And we need some certifications around all of these using correct PP. Other day I was talking that we all use harness. Now we suggest all the vendors, contractors, to use harness with shock absorbers, so that it should not leave, even if it doesn't kill the employee or worker, even if it does not fall down. But if you do not use that shock absorber kind of harness, it may lead serious injuries to his backbone. So these small changes are required. I'm just skipping all of this. And in Tata BlueScope, we give a lot of importance to sustainability. One is a Jagriti campaign. Throughout company, we celebrate, we bring awareness about the different days, important days, which talk about nurturing the culture in the organization. We talk about National Renewable Energy. We talk about Site Day. We talk about Bus Stroke Day. In all our plants have got solar power panels here. So we use almost 65% of energy of our Bhiwadi plant comes from renewable energy, that's solar power plant. And in Bhiwadi, it's as of now, it's on almost 7% of energy comes from solar power plant. We use most of the taps, use less water, almost 50% less water we consume by going for mist kind of waters instead of regular tap. We give a lot of importance on tree plantation. And as I was talking EPD, we are the first one in the country to get this certification, which talks about it entire life cycle analysis. We're the first one in the industry to get green rating integrated habitat, that's RIA certification. And again, as I said, we also got Green Pro certification. This is what I was talking. All our products, they use Thermatec technology so that the SRI value is a bit high. It is higher so that the temperature below the room is much cooler to the extent of 6 degrees. So it works on SI principle. We also have sort of brought innovation in the solar journey. We also make modules for solar power plant. When in 2010 we started solar journey, if you see here 2010, 1 megawatt to make 1 megawatt, the industry was using 130 tons of steel. And by 2019, we brought a lot of changes in innovation with the help of a lot of stakeholders. We did not do all alone. And now we are able to bring the design down to 27 tons per megawatt, from 130 to 10, almost 90% reduction in the steel consumption. So that has also impacted favorably to reduce the carbon footprint, besides bringing down the cost of the structure. These are some of the pictures of the solar modules as well as the solar rooftop. All our profiles that we make, they are compatible with solar cells, solar modules. That means on our profile, the solar module can straight away fit over it. As I talk, safety is the core for us. We do a lot of re-roofing, retrofitting. That is again important element of sustainability or you may say climate change. Instead of just this is how you reuse the building, you increase the life of the building. You can see the left building, how it looked like earlier, and now it has been totally retrofitted and remodified. Same way here, these two buildings. And this is a new initiative for skill development, which we have initiated in collaboration with the CIDC, where we have initiated a plan where it's totally funded by us. And we, in the first phase, we are going to develop the skill of almost 100 workers across the country. They will be staying there. It will be a 3-month course. They were staying in the centers of CIDC. And we try to develop the skills towards different areas of the construction, including steel construction, which again we feel requires some more focus to manage the sites properly. This was widely accepted, this was widely recognized, and a lot of people appreciated that. This program of Kavach, we had 2 programs, on-site program as well as the program which we have said, curating with CIDC. So 2 programs on-site, we did the 2-day program. And this was covered widely by newspaper, media, and the employers also. As I said, day before yesterday, I was in Odisha with Tata Steel Angul and Tata Steel Kalinganagar. Both the vice presidents, they felt that we should do more of such program for their sites also, and increase the horizon to all the workers at the site, not only those who are working for us. So these are some of the awards we won. You can see the steel building. They are not traditional steel buildings. They are very beautiful building. You talk about any applications and they are beautiful in all nature. One building I want to show in particular, this building. This is admin building of BASF. You can see how beautifully it has come out using our steel profile as well as some unique colors. As I said, we use only environment friendly colors. Even if the request come to produce some colors like yellow or red, we don't use lead. We use only lead-free pigments so that they can be used for one, rainwater harvesting, and they are easy to recycle. They do not harm the nature. And I leave the forum with these 4 issues or the challenges that the industry is facing. Thank you. Thank you all.
Thank you, Mr. Rathan. It's very interesting because we generally don't see such steel buildings around, and there has to be. And I'd like to congratulate you for all the awards that you have received. And it's really nice to hear that you are interested in having women workers on the site, because this is a problem that we at CIDC have been facing. We train them in general work supervisor, electricians and all that, but then the industry, there's a very little acceptability, I would say. no acceptability at all when they're working on site. Their workers agree, they're engineers, they're architects, but the mid-level, we are having issues. So very nice to hear that you're open to that. Thank
Thank
you. And I'm sure people would like to ask questions during the question and answer section.
Thank you.
Thank you. For the next session, I would like to invite Shri Vivek Naik. Mr. Vivek Naik is the Managing Director and founder of Apple Chemi India Private Limited. He is a civil engineer and has a postgraduate diploma from IIM Ahmedabad. He is a former president of Indian Concrete Institute and a member of ACF. So he is going to speak on recycling of concrete to reduce the carbon footprints. Generally, we don't think about recycling. It's been a very interesting topic, and I look forward to hear you. I'm sure everybody is looking forward.
Yes.
Welcome, Mr. Naik.
Yeah. Dr. Suchita, can you tell the other person to unshare the screen, Mr.
Okay.
Rattam? Because that screen is still going on.
Is it still visible?
Yeah, Ajay, it's not gone yet. Can you please see?
Oh, I'm not very tech savvy.
Yeah.
A bit,
It is gone. Okay. So now I guess you can review it.
but I think from my end, should I leave and again join? I think that's the best way to do.
Yes, you've done it.
Have I? Is my screen still visible?
No, now your screen is not visible.
Okay, thanks. Thanks. I'm so
And yes, so we have Mr. Naik's screen. Thank you. You could make it full screen.
Yeah. Can you see my screen?
Yes, we can.
And Dr. Suchita, you can hear me also?
Yes, we very well.
Yeah, yeah. So good afternoon, everybody. This is Vivek Naik. I would like to thank the organizers, CIDC, for giving me this opportunity to speak on such a wonderful topic, which is, I think, in the world that everybody is talking about, sustainability and good management practices on energy efficient buildings. CIDC, I understand, has signed a MOU with Ministry of Environment and Forest, and we are looking in for putting up a lot of our inputs to give something from the construction industry also, because the construction industry is one where I come from. And if you see the stakeholders of construction industry at large are the concept designers and architects who are planning the overall scenario. So also geotechnical engineers and structural engineers who are designing the building, project management consultants who are looking in for the management of the project, government, semi-government organizations, wherein huge amount of stuff is being done all over the world. So also industry, factories, and industry, even individual housing and infrastructure creators. So these are the people we are going to talk a little bit more. To have an eye on the renewable energy, we are planning by 2030, we should be using 50% renewable energy. And India has also taken up a challenge that carbon footprint will be reduced by another 45%. But the biggest goal in my view is we are planning for net zero carbon emission country by 2070. So this is a combined goal with the everybody in the world, and India wants to lead this. If you see the overall scenario, in the morning, Dr. Swaroop and even Suchita discussed about the Montreal Protocol, wherein India has also signed that they will be a party to reduce the carbon footprint and reduce per capita energy consumption. Now, if you see the right-hand side of the screen, per capita energy consumption, that is per kilowatt hour per person per year, in USA is somewhere around 13,000, whereas the global is somewhere around 2,670, and India is only 1,181. So I can say that, well, we are in the lowest a contributor to this problem, and the basic issue lies in the Western world. But yes, there is a serious concern also why Western world is into this scenario now. We will have to understand. Because they, I will say, misused the infrastructure facilities, they misused the natural resources to very large extent, and now they are facing the problems. And today, India is one of the fastest growing economy in the world and fastest construction industry also in the world. Now we will be contributing more and more, and we should not land up into the similar situation as what West is facing. If you look at this building sector, yes, India consumes 30% of the total energy in the construction sector itself. Now, if it is going to grow very fast, we will have to be careful. And then here is a more serious thing that construction industry should look into. If you are talking about the target, yes, India has set to achieve 500 gigawatt of renewable energy by 2030. And out of that, today, what India produces, the energy, is still 62% is thermal energy. Let me tell you, friends, when you are producing thermal energy, we are consuming coal and we are consuming water. That is how we produce the energy. And that is again depletion of main two big natural resources. So also we are producing only 12% energy from hydro. My main concern from nuclear power, we are producing only 2%. We should be focusing a little more on that. And we should be focusing more and more on the solar and wind energy, so that the thermal component of energy production should be reduced to more a lesser portion. Recently, I saw that our Honorable Prime Minister has already projected that India will be going towards the climate change COP26, which is signed with the United Nations Conference, and we will meet 50% energy reduction, which is non-fossil, which will be renewable energy. And this is a very big challenge, and we all have to participate in this effort. I just peeped into IGBC side the other day when I was talking to Mr. Suresh, who is the president of IGBC, and their side says that the framework of IGBC is to reduce, recycle, and reuse the products so that you can design better and have a holistic. The compliance of all this, such a simple sentence, can be done by what is the quantity of the waste we produce and what is the quantity we are generating. If you see the compliance, the quantity of waste, the landfill, is equal to the quantity of waste generated minus the quantity reused. My more motto is to do the minus part, that we should be using reducing, rather we should be reducing the quantity of waste generated, and we should be doing more of recycling. When you do this minus, then we will be in a better scenario. To throw some more light on that, I will be coming on that in the preceding slides. Little bit on net zero carbon. Building construction industry contributes 28% and of the energy carbon emission, and in the industry carbon emission is 30%, transportation is 20%, and building industry. So we are a serious contributor to the carbon emission, and we should be taking more measures. About the measures, passive cooling, I'm not expert, and Dr. Agrawal and Vikram Murthy sir has already talked about it. I'll be concentrating more about the passive cooling also, which is a cooling other than the mechanical cooling. I'll be concentrating more on the construction industry. Yes, today we are doing the construction with RCC using good amount of energy and also creating good amount of industry. The standard practices what we are using today are using very costly material as far as the energy input is concerned. But in the global scenario, what we should be looking in for is a cradle to cradle concept. Like you have raw materials and you manufacture various products, you transport these products, and you use these products into the building. And when the building life is over, you recycle this. My emphasis is to recycle the building waste, and that will give us the better edge on the overall scenario. Day before yesterday, yes, that is on 24th of August, High Court has advised the twin towers in Noida to be demolished. See, these twin towers were constructed illegally. Initially, the permission was for 9 stories, then it was raised to 12 stories, and then it has gone to 26 stories. And then there are many legal issues, and court has told to demolish this building. But my area of concern is the right-hand side of yours. The demolition waste is going to be 35,000 cubic meters. I don't know what is the plan to handle this huge kind of debris. And for me, this is a goal. I can reuse it and recycle it and use it very fruitful. See, if you are talking about the other ways wherein the C&D waste, that is construction demolition waste, is getting generated, it is demolition of old structures, demolition of buildings and structures during earthquake and wars, which is beyond our control, removal of unusable concrete from the structures and buildings and roads when you are doing restructuring. Not only that, the huge concrete waste is generated when we are disposing of the cubes, cylinders, and non-destructive testing methods, which are being used everywhere. And you will be surprised to see the quantum. In 2016, it was somewhere around 112 to 331 million tons of construction demolition. This is in 2016. Today, what must be the figure? I am quite sure this figure might have gone even to 600 or 700 million tons. Friends, I would like to invite your attention to one simple fact. India is producing almost 390 to 400 million tons of cement. 400 million tons of cement we are producing, and we are producing 700 million tons of C&D waste. This is something huge. So what is the only method is to use construction waste. See, it is produced at the simple cycle is you have a demolition of the building, you have demolition of roads, you have demolition of cubes. All this can be used for the subbase of the roads very effectively. Otherwise, you can crush all the ingredients from the C&D waste, and the fine particles can be recycled and added into the new concrete. They can be used either directly into the new concrete as supplementary cementitious materials, or you can make fine powder of it and add it during the process of making of cement. Again, coupled with some special admixtures, you can use this cement and do the new construction. We can recycle substantial quantity, almost 70 to 80% can be recycled. There are some challenges. We will discuss this in the forthcoming. There are great benefits in recycling of the concrete, that yes, you can use the local product at the site itself. So there is no wastage of energy by transportation, because transportation sector is contributing to more than 20 to 22% of the energy. And we will be having a renewable resource. So also there will be cost saving, and this will be disposal free, because whenever the disposal is done, government is charging for some disposal fees. The biggest challenge lies in the how to handle the recycled material, demolition material. As you can see in the photograph, there will be a lot of steel, there will be bigger diameter steel, lesser diameter steel, there will be plaster, there will be a lot of brick, there will be blocks, there will be concrete of different grades. And this all cannot be mixed to use it. So we will have to have separation. There are various plants. I'm yet to see a good plant in India, but I had an opportunity to see some plant around 6 to 7 years back, which I was talking to about Dr. Sarup the other day in Mumbai. And this has led to this discussion today. I am here talking on the same subject. So yes, India generates 150 million ton. Again, that is a figure in 2016. And see, the reuse is only 6,500 million tons per day. Let me tell you, this 650 tons is also not being used very effectively. This is just a landfill and all. So we are practically not using our technologies and best of our abilities to address C&D waste. When I was president of Indian Concrete Institute, and around 6 years back, Indian Concrete Institute has produced one document. This document is under discussion with IS also, how to use the do the recycling of the C&D waste. And the index is quite explanatory, where there what should be done with the policies, guidelines, recycling waste separation, demolition waste separation, what are the innovative methods. And all those who are interested in having this book, they can give their names to CIDC, and Apple Chemie will ensure that they get a free copy of this particular book, so that we can also contribute to this beautiful cause of sustainability. There are various codes nationally and internationally. I don't want to talk about that. There is TFAC 2001 also, which is talking about C&D waste utilization. But as an individual, I would like to say that we should make it compulsory that whenever you are making a new construction, at least 25% of the material should be recycled, and it should be C&D made from the C&D. If there is a government law regulation, we will be saving a lot of money, and we will be doing great to the country. To strengthen this, Niti Aayog has signed with Ministry of Housing and Urban Development, and they are going to be responsible for making laws and drafting policies about using of this C&D waste. And so also there will be templates, and some knowledgeable people will come forward under the umbrella of CIDC, but that will not be sufficient. Government regulations will have to be forced on use of, rather the compulsory use of this aspect. So that is the one important aspect. And in next 5 to 6 minutes, with your permission, I would like to tell some of the important materials which can again contribute to sustainability and to the present topic of making the scenario green. My urge is to use supplementary cementitious materials, use higher range superplasticizers, durability enhancing additives, so also preventing rust preventing materials, and some thermal insulating material. I will quickly go through this because this may not be directly connected, but yes, as a specialist into the construction chemical industry and a technocrat into the concrete technology, I would like to tell you some of the materials which can definitely contribute to sustainability. Yes, these are the supplementary cementitious materials: fly ash, GGBS, metakaolin, and microsilica. This is what it is, and they can be used with the help of innovative superplasticizers, because you cannot directly use them. Yes, at Apple Chemie, we have developed a viscoflux technology, which is also a patented, and these superplasticizers are being used in the benefit of the construction industry at large. They are of 3 types: water reducing, slump retaining, and hybrid type. You can get many advantages by using the viscoflux technology. You can reduce water cement ratio, you can lower the permeability, and you can make concrete better and better. And these are some of the shots of our initial deliveries. of PCE, which we developed. Unfortunately, we have been appreciated by FICCI as one of the best innovator in the construction chemical segment in the interest of the nation. So also we have taken this opportunity forward and we have gone in for a manufacturing process of making PCEs with practically no energy. So this is also one very good initiative from our side, that we have modified the energy consumption, and the embodied energy in the viscoflux is much less than the other energy used in the other PCEs. So is this enough for the sustainability? No, we can also use some of the products which can add to the durability of concrete. That means they will be reducing the cracks within the concrete and they will make concrete more sustainable. This is one of the products which is Apple Chemie has developed. It has got IS. It is produced by ISI. It is a patented technology and it has got X-ray vision. Those of you who are interested in this product, I will talk to them in person thereafter. This is being exported for CE, and Ministry of Surface Transport, MORTH and IRC has given a special approval, and special appreciation and testing has been done by CSIR on this product, so that this can be used, and this is available in bulk quantity. Practically, India is the only in India, Apple Chemie is the only company which is supplying this particular product in bulk loads. And if you are talking about the sustainability, there is some angle on the reinforcement, which is getting rusted within the rebar and giving a lot of issues to the concrete. If you are talking about the materials which are being used in the construction, the corrosion of steel is of a serious concern, and there are various researches which are done about the corrosion, and I will not go into the details. I will only see that there are some products which are developed as a bipolar corrosion inhibitor and they should be used. And if you are using bipolar corrosion inhibitor, this is one wonderful study done by Dr. Radhakrishnan from IIT Madras, which shows that if you use bipolar corrosion inhibitor, life can be as long as 31 years to the rebar, which is untreated rebar. And if it is without bipolar corrosion inhibitor, it can be only 9 years. So these are the things. And so also there are some sustainable materials like curing compound, which are used by L&T. Just your 1 minute on that. When they started Mandvi Bridge at Goa, they said that they will be using Apple Chemie construction chemical, which is a curing compound, on 8th of September 2016. And in 2019, they gave again a statement, again in Times of India, that they have saved 10 crore liters of water only by use of such construction chemical curing compound. So this is a huge saving just in one bridge, one infrastructure construction. If you can save this quantity of water, if it is used all over India, we will be contributing a lot. There are some other energy saving products also, but the better authority is Mr. Vikram Murthy and Mr. Agrawal, who have already touched this type of products. Just to tell you one last thing, that we can be also using products where it can be cement free. Instead of cement, you can use geopolymers. And these geopolymer concrete are quite good, and they have a very high resilience with underground susceptible other parameters. They can be light in weight, and they withstand very severe aggressive conditions. And I got a chance around 8 to 10 years back. Even some of the geopolymer segments for the metro have been constructed in Canada, and they were doing the launching with that. And let me tell you, friends, this is without cement. This is without cement. So you can definitely save. I'm not against the cement manufacturers, but you should be always going in for some other alternatives. So we are working with various universities on that. These are the scenarios. Dr. Katkar. She was in our office, wherein we are working on some special geopolymer concrete, and Anna Bras from Liverpool University visited our factory. And to end my discussion, I would like to urge everybody that we should be going from renewable energy, from gray concrete to green concrete. We should be using more and more of green concrete, and green concrete should be made mandatory with the use of sustainable green materials and use of some portion of demolition. With that, I would like to close. I think I have dragged a little bit more, but thank you for bearing with me. I thank CIDC for giving me this opportunity. Thank you very much.
Thank you very much, Mr. Nayak. It was really interesting. And I think it is the way forward in construction. We have
Yeah.
to recycle material. We have to use it. There's no way out. And we hope that this platform will help making things mandatory as suggested by you.
Yeah.
And also regarding embodied energy, CIDC has been working on it for their green initiative. We have that in our Vishkarma Award segment, and we do it. And
Yeah.
Mr. Niranjan is also working on these things.
Yeah.
So that is what we can join hands and do things and change the scenario. It will be wonderful. Thank you.
Thank you. Thank you.
Actually, with this ozone cell, we have also tried to understand the awareness level of the industry as a whole. So we conducted a survey with a lot of people, and then we are trying to understand and make a report. Mr. Niranjan Swarup is working on the same. So he would be telling us about the things that we think should be done and what is the way forward. And his presentation, Dr. Professor Niranjan Swarup is the Director General, Indian Society for Trenchless Technology. And he is also the Honorary Director in CIDC for Higher Education. Today, he's going to speak on good management practices for introducing passive cooling designs and promoting the use of non-CFC and low GWP alternatives in building construction industry. He is the one who is writing the report on all these things that should be done. So, Mr. Niranjan Swarup, I invite you to take the floor and your presentation.
Please give me the screen.
Yes, please.
We have given some.
It says host has disabled. Yeah, got it. क्या करना है? Good afternoon, everybody. So I hope my screen is visible.
You can make it full screen?
Yeah. Is it visible now?
No,
Yes, sir.
it's not
But
full
I
screen. It
think
is
I have
visible.
opened a wrong presentation.
Okay.
I don't know why it is opening the old one only. Is it the CCI I'm showing?
Can't see it now, but yes, all the three were the same.
No. This is CCI, construction cost indices presentation, I think.
Manage कर दिया।
Video and everything's off.
Okay. Now my presentation is visible.
Yes, it is. And you can make it full screen now.
Yeah, just a sec. All right. Now, what I'm talking is about good management practices for introducing passive cooling designs and promoting the use of non-HCFC and low global warming alternatives in the building construction industry. We have been talking about all these things in the previous, like in this particular workshop, as well as in the last 3 workshops. This is the 4th workshop of the series. And the primary objective of this particular series or this particular activity is to promote the good management practices which are needed for passive cooling designs and introducing non-HCFC and low GWP. What I will be talking is the introduction, the scope of passive cooling designs in upcoming building construction, consultations, status of available skills, survey of existing practices, skill gap analysis, survey outcomes and recommendations, and then the concluding remarks. Ministry of Environment and Forest and Climate Control entered into an MOA with CIDC, and based on that MOA, the point or the logic was to go ahead for the HPMP, that is hydrochlorofluorocarbon phase out management plan, stage 3 implementation. Prior to this stage, the ministry had worked out on the India cooling plan, or that is something where they decided how to cool the whole nation or how to provide the cooling to the whole system. And it was discovered that building industry is the building consumers are the last ones which are end of the chain. And if they work out, the energy demand can be reduced. I would like to cite here a news article which I saw 3-4 days back. And that is that in China, is about 15 to 20% power supply has gone down because of the low rains, and the 15% of the power supply depends on the hydroelectric power supply. Now, this has forced them to shut down malls. This has forced them to order closure of plants in, or rather reduce the demand of energy. We were an energy deficit nation some time back. We have come to a strong, or rather a proper nation using good amount of energy. Now we need to be judicious that that energy is spent properly. And the amount of energy which is going to be consumed in cooling, we need to reduce that. And we also need to reduce the ozone depleting substances, as we have been talking all in this series. CIDC is working with the ministry. CIDC is working with various organs of construction industry, and the intent is to convince people, or rather to mobilize the whole concept into getting all these things in the operation. This presentation basically is structured similar to the report that we have almost prepared. There are certain approvals or certain changes which are being included, and once that goes through, this would be put up for the approval of the ministry, and we believe that the same would be released by the Honorable Minister on the Ozone Day, which would be the next month. So the broad objectives of the implementation of the activities related to building sector component of HPMP2, or that is hydrochlorofluorocarbon phase out management plan 2, under the MOU were aimed at sensitizing the construction community as well as the users towards the benefit of energy efficient buildings. That is what we have been doing. That is what our learned speakers have been speaking all through. Organization of consultation and awareness workshop. We are on the 4th workshop today. Secondary research, that is what we did from the initial interactions that we had with the industry stakeholders, and based on that research and the literature review that we performed over the available codes and available energy efficient construction systems, we came up with the possible needs for implementation, and they were basically landscape, and the trends were evaluated that what is actually happening, and then we developed the methodology how to implement that and implemented it. So in brief, this is what we have done, and this is what would be detailed in that report. As I have discussed with the officials of the ministry, we believe that this book is going to be used as a reference manual once it is released, and I welcome all of our participants to have a look at that. I know there are academia people, they would need this to use it in their the regular operations or regular teaching actions, so that they create manpower which which understands the whole system. So now the first section would be the scope for passive cooling designs in upcoming building construction. Now, we basically analyzed the ECBC norms, that is Energy Conservation Building Code norms, and then there are for Eco-Griha also, all those norms have been established. We went through the green rating process as was being discussed earlier, just before my presentation. We conduct the comprehensive green rating, and that is called CIDC, Comprehensive Green Rating, CCGR, that we conduct along with the Vishwakarma Awards. All the applicants of the award, they have to go through this rating process so that we can evaluate whether they are following the environmentally sound practices, that is ESPs. And then India Cooling Action Plan, this has been devised through the HPMP by the ozone cell in the HPMP stage 2. Now, what we are doing is we are trying to implement all that in the nation through various actions or various interventions. And I would require all of you to join CIDC and enable it to be implemented so that we can avoid the fate as certain other nations are having. Like there was a mention about compulsory temperature fixation of certain temperature in different nations. In India, till today, that has not been done. But in Europe now, Sweden and some nations, they are basically fixing that the minimum temperature must be 24 or 28 degrees centigrade. So understand the need and requirement of this, because the higher the temperature, lesser energy you would be consuming. Now, we went through the consultations with the members of the construction community, the building designers, architects, urban policy makers, building developers, building development associations, etc., to begin the whole process. And that process started when we initiated, when we signed the MOA. After that, the memorandum of agreement. And after that, we had these consultations, direct consultations, Vishwakarma Award, visit consultations with our students. We teach a lot of people in vocational skills, starting from there to interns, to engineers, our trainees, all those people we discussed, and we came up with different point of issues. The stakeholders whom we consulted included the Bureau of Indian Standard. Now, we are part of the BIS construction group committees. So we discussed there. We are part of Engineering Council of India. We discussed issues with ECI. We talked with various universities. We have numerous MOUs with different universities and colleges. We talked with them. We talked with the project owners, manufacturers, vendors, then vocational workers. Based on that, we got the inputs and we prepared the outcome and recommendations on that. The status of skills, what we discovered of the existing manpower engaged in the building construction activity with respect to passive cooling concept is like this. If you look at the this particular matrix, 0 to 10% knowledge level was demonstrated by almost 67% of the people. But then when we come to the implementation level knowledge and implementation level understanding, it was very low. We talk about green building concepts, we talk about environmentally sound constructions, but the sad part is that we know it from the viewpoint of watching a certain educational television channel. Not beyond that. Yes, I need to know that there has to be material which can be reflecting the radiation or heat. I need to have material which can absorbing the heat. These two combinations can help me to create a situation or system where my building is passively cooled, or I require lesser amount of cooling energy, or the SCFCs and global warming products are reduced. But then how do I apply that? That is something where we require intense interaction, intense exposure, sensitization, bringing the awareness within the systems. Even the design systems which we were talking in the morning, they have to be inculcated with the educational systems. They have to be inculcated with the practicing engineers. So based on that, we conducted the evaluation and we came up with these situations. These included the information of sector present in the status in respect of passive cooling concept, future growth in the sector, skilling of the skilling and certification needs in respect of ODS, that is ozone depleting substances phase out, energy efficiency, safety and alternative refrigerants, occupational safety, access to finance and social security schemes, and recommendations for the sector. This is what we would be presenting in that report. We would also be presenting different solutions possible as we have decided. We will be talking about that subsequently. We conducted, based on the interaction, we created a survey form, or rather a survey where we asked different questions that what is the level of awareness, what is the level of application of the passive cooling design systems in the building construction industry, and usage of non-SCFC and low GWP alternatives therein. And the responses gave us another picture, which is, I think, which tells us various distribution of the understanding. The survey methodology was devised to seek the following inputs, that is the basic understanding of passive cooling and usage of non-SCFC, low global warming product materials, understanding about the possible benefits of passive cooling and usage of such materials, checking the availability of relevant codal provisions useful for HPMP stage 2, status of applications of such codal provisions in the building sector, knowledge of such provisions with the applicable professionals, applicators and professionals. Now, the thing is that most of the people are aware of these. Most of the codes are functional. There are stipulations, there are rules available, there are specifications available. The only thing is we need to provide that linkage between that knowledge of that information with the practitioners or the applicators. If we are able to do that, we'll be doing laurels, and it will be a great thing for the industry. Now, what we did in the survey is the actions. What we took was we asked the current application or usage patterns about the usage of passive cooling systems or non-SCFC or low GWP products or alternatives in the usage. We identified the knowledge gap, that what is the level of knowledge gap actually happening in the industry, evaluated the available operating and execution skills in professionals and artisans serving the building sector. That is how we identified the skill gap, identified the guidelines for the skill gap closures, and developed the good management practices for the realization of HPMP stage 2 objective for building sector. See, till before this particular initiative, there were systems, there were processes, there were materials, there were products which have been created to attain the natural cooling or passive cooling, to reduce or remove the SCFC products or high GWP products. But then end of the day, what we need is to get those implemented. And who implements that? The people who are actually working in building construction industry. And that is where this particular effort has been done, and I'm confident that if we are able to implement these, it would be a great thing to handle. Now, with the survey process, we knew the survey existing practices, organization of consultation and awareness workshops, development of questionnaires and survey with the target stakeholders. We did conduct the skill gap analysis and suggestions for incorporated the passive cooling designs to achieve the objective to reduce the cooling demand. Now, this is what is the outcome of that skill gap, or rather that knowledge matrix. And we require knowledge level enhancement requirements we identified, and which went from 90% to 0%, and the values are 67% to 0%. So almost 90% of the people require certain trainings which start from 10% going up to 90%. There are nobody who does not require any training. That is what the primary outcome of my, or rather our interactions and surveys produced. It also demonstrated what are the issues which need to be addressed, and then what are the suggestions or what are the recommendations from the survey. Now, we went in for the interaction details, respondent observations, we identified the issues, recommendations were made for the future course of action, proposed action with major stakeholders, and roadmap for implementation of recommendations. Now, what did we identify? The first thing is absence of rules and specifications for passive cooling with urban local bodies. The rules and specifications have been identified in India Cooling Action Plan, ICAP, MOUHA, that is Ministry of Urban Affairs, and Ministry of Housing Affairs, has Ministry of Environment is working with MOUHA, and these are being included in the rules. The requirement is that we need to get them implemented on ground. The rules would come, but then unfortunately, if there is nobody who's forcing it to be implemented, it will be difficult to kind of actually brought into the picture. Visualize that you are living in a city like, let's say, in New Delhi. In Delhi, if you are living in an area where the municipal laws tells you that you have to have such kind of setback, you need to have this kind of building operations, but it does not tell you that what kind of thermal preventive things you have to put in. You will not be putting it in. So what we need is to get those rules and specifications in place. The sensitization levels of passive cooling and low non-SCFC and low GWP alternatives with the majority of people is less. People do work, but then they do it whatever is written in the specification. And if the specification does not say that the passive cooling is needed, they would not get in. Poor awareness about the various code provisions. We have the ECBC codes, we have the National Building Code, the BIS, Bureau of Indian Standard, or the Bureau of Energy Efficiency, BEE. They are trying to promote both of these codes, and these form the backbone to prevent, or rather to reduce, the energy consumption. Awareness about them is low. We need to enhance that. Then we have high skill gaps with the executing individuals, less coverage of concept in the professional curriculum. The engineering profession, the diploma or the polytechnic curriculum do not very clearly look at the what you call the coverage concept in the coverages of what we call of the passive cooling or non-SCFC or low GWP alternatives in the curriculum, and we need to bring that. Low strength of faculty members having adequate knowledge base of the subject matter. We have professors, we have lecturers, we have demonstrators. Their strength, the people who really are aware of the systems and how they have to be implemented, for the strength of those people is less. We need to enhance that. Absence or lower availability of training infrastructure, equipment, or other related parameters. End of the day, if I have to tell my student that, look here, this is how you are making evaporative cooling. So now I need certain fixtures, certain items in my laboratory, in my college, which are run and systems are explained to my student. Now, if I don't have that infrastructure, sorry, my boy or girl will not learn that. So that is the next issue. Low finance availability for upskilling of the working professionals, tradesmen, and vocational artisans. Unfortunately, when we graduate somebody, he would not spend or invest on his education or the continued professional development. So we have that kind of hiccup that how do we get these things moving? We need financial inputs for that. And then last is the absence of procurement conditions and specifications with major infrastructure owning agencies. Organizations are procuring materials, services, structures, whatever. But if they don't specify that I need this kind of inputs, the specification will not force the contractor or the supplier to get into this kind of system. So we need to get those procurement conditions stipulated. So these are the 9 issues we identified. And these are the recommendations which are going broadly so that we can work it out. Implementations of rules and regulations at municipal bodies or ULBs. This would be done through MOHA, the ministry, and the interested stakeholders who can work with the ULBs, urban local bodies, enhancing the awareness of code provisions within stakeholders. BIS and BE is promoting that, and we need to assist that ministry, and all these recommendations CIDC has proposed to work along with the ministry. So next is the enhancement of awareness of the codes. Then high skill gap within the executive individuals have to be reduced, and that reduction has to be done through focused trainings, exposures, and many more things like project visits and paper writing, conferences, workshops and all. So that is there. Then less coverage concept of professional curriculum. For that, we need to work with All India Council for Technical Education. All these recommendations have been made. Low strength of faculty members having adequate knowledge base of subject matter. The people who are from the academia who have joined it must be knowing that we are conducting programs in a stream called Samarth, which is the ASALP, that is for developing the faculty members. We would like to put these things therein and work with AICT or different organizations organizing the trainings. Absence and lesser availability of training infrastructure, equipment, and other related parameters. This is something where the engineering institutions, the polytechnics, all have to see how to organize that. And we have to look if we can find some kind of operations. We have given this recommendations to them. We have prepared the recommendations. The recommendations are yet to go. The low finance availability for upskilling the working professionals, tradesmen, and vocational artisans. For that, there are ways and means we have proposed, and let's see if they can get in. Absence of procurement conditions and specifications with major infrastructure owning agencies. Here we are again proposing that using the CIDC database and using the things. Now, these are the 9 issues we identified and 9 recommendations we have made. I throw the request to the audience and to the people who are listening to me, the request for any more ideas they have, they can send in writing to us so that those could be also included in our report. With the growth of society, the demand for cooling energy is also growing at a fast pace. Supply of such quantum of energy could lead to extensive use of conventional energy sources, as non-conventional sources would not be able to cope up with the demand on their own. Solution to this environmental challenge is to reduce the energy demand for active cooling. The more passive cooling we go in for, the lesser active cooling we have to implement. And if the lesser active cooling is done, obviously we spend lesser energy. The passive cooling methods are the best solution in this case, as those create environment within the building envelope with lower active energy demands. Such design processes provide solutions through the spatial arrangement of the building envelope and usage of appropriate material to optimize energy consumption over the complete life cycle of the structure. May that be cradle till grave. Every place we need to see to it that they consume the least energy. Let it be material energy, let it be transport energy, let it be the demolition, and let it be disposal requirements. All those need to be as low or as best as possible. And obviously, the green rating systems do come into play on a major way in this. The use of ozone depleting substances, at the other hand, is also harming the environment, as has been highlighted by Mr. Agrawal at the beginning and by other speakers as well, and also all through this series of workshops. To address these issues, the ozone cell MOEF and CC has taken a major initiative in the shape of HPMP stage 1 and 2, where HPMP stage 3 is under approval. Actions till the initial part of HPMP stage 2 produce solutions by way of India Cooling Action Plan 2019, development of solutions linked with non-SCFC, low GWP alternatives for refrigeration and air conditioning, that is RAC industry, for active cooling system. The next step in this initiative is to implement such solutions aimed at reducing the demand for active cooling energy for building construction industry. In current initiative, CIDC is working with the MOEFCC to promote the passive cooling and the use of non-SCFC and low GWP alternatives in the building construction industry. Under the MOA, CIDC conducted a study and determined the needs of the industry and has recommended solutions to MOEF and CC. Such solutions are being put up for due deliberations and upon approval shall be put up for implementation. This presentation discusses the study report and the recommendations in brief. We invite stakeholders to work with us to get the ideas implemented and protect the environment. Let us not end up in a situation where the power generation again falls below the situation, like falls below the basic demand, and we are again forced to major power cuts. So with that, I would like to conclude my presentation. Thank you very much for your attention and look forward to working with you on this important nation building initiative. Please, please, please send us your suggestions. We would like to include everything which can help to make this particular initiative successful and conserve energy as best as possible or practical. Thank you very much, Dr.
Thank you, Narendran, for the presentation and sharing the report details. And I'm sure people would now like to give their feedback. I have mentioned in the chat box our email address. It is cidcfbd1@gmail.com. You'd like to share your feedback? We're looking forward to it. And now, yes.
Just a question I have.
Hmm?
Do we wish to circulate the questionnaire to the current participant base as well?
We will, yes,
We should.
yes, we will.
At least they should also let us know what are their thinking. They might have joined the program or they might not have. If they have joined the program, fine. If not, let's see.
Yes, we'll send it to all the participants who have joined this time. I'm
Yeah.
sure there would be some repeat participants whom already have received the question. We'll do that. So now the floor is open for discussions. This was the last presentation. Anybody who would like to say, Dr. Sivu, you may take over the question answer session.
Yes, thank you, Dr. Kumar. And once again, nice to be on the floor and talking to all of you. Let us begin with the question answer session. And any short and very brief comments that you may like to make, of course, you can always send it across, which we'll be deliberating with our eminent speakers and taking certain measures which are basically mandated. So let us begin with the questions. And I am just keeping the floor open. Who's going to be the first one? Dr. Kumar, it looks to me that this is very close to the lunch time. As a matter of fact, some time has also gone by. So there may not be many questions that will be coming. And therefore, I will basically your written comments and suggestions, and also tell us the areas that need attention. We'll take care of it. And please feel free to also participate in remaining sessions that we have there. There are always new initiatives that we are discussing. There are different kind of technologies that are being deliberated upon, and it is going to be so enriching to everyone. So I will thank all the eminent speakers and the kind of wisdom they have brought to everyone who participated in this program. And with that, I think we can call it a day and then go ahead with our lunch. Thank you so much. Goodbye and Jai Hind. Thank you.
Thank you, Dr. Saab. Very kind of you.
Thank
Thank
you.
you.
Thank you.
Thank
Thank you.
you.
Thank you.
Thank you, Dr. Saab.
Thank you. Thank you.
Pleasure.
Let's see you in our next workshop, which will be announced shortly. Have a very good day.
Thank you, ma'am.
Thank you, Suchita, madam.
Thank you.
Thank you very much.
And I suppose all of you have seen the email ID. You can connect us there.
Yeah.
Yes, ma'am, we have seen.